Welcome to Math 9 and the PM. This is the Digits and Diamonds back at you. And a big shout out to Rami, who's been, what have you been doing? You're not even sure. He's up to so much business. Okay, now we're doing math. That's all that matters. 7.1, skill diagrams and enlargements. It's 318 in your textbook, but number 1 in your hearts. And we're going to talk about metric conversions first. That ain't in your textbook. Now, I need to talk to you because some people remember this stuff, some people don't. This is a meter, right? And according to that, there's 100 of these centimeters. And on this side, it has just centimeter markings, right? You guys realize the centimeters, for me, I got fat fingers-ish, but not fast, but they're a little, my pinky finger is a little wider than a centimeter. But you kind of get the idea of a centimeter. There's 100 of those. And it's easy to remember but I'll remind you in my classroom, but I won't be with you all the time, because I think centimeter, and if you ask me how many centimeters in a meter, I'll say, okay, how many cents in a dollar? You say, hey, 100, yeah, sure we're listening. And then I might ask you, how many years in a century? You would say, oh, come on. 100, yeah, okay, so 100 centimeters, cent means 100. It's a prefix that means 100. Now, millimeter, I won't go through a list like that. Who knows French, though? Anyone? Okay, no. You know what 1,000 is in French? No. Okay. I'm pretty sure it's milli or something like that. It sounds like millimeter, and that's where it comes from. Anyways. And knowing that, this is the millimeter side. There's 1,000 of those little tick marks in this meter stick that I'm holding up, right? Within 1 centimeter, there is 10 millimeter marks. These are the ones we're going to work with. You should actually be aware of kilometers, 1,000 meters in a kilometer, and stuff like that too. For the purposes of this unit, these are the 3 facts that you're more or less going to need to know. Okay. Now, I'm going to, and I mentioned this right here. Like when I handed this out, one of the students said right off the bat, had them done just without even thinking. There's many ways to think about these problems and solve them. I'm going to just show you one way using fractions. And this fraction system we'll talk about it more, it's called proportion fraction. But if you know a way that works for you, just stick with it if it gets you the right answer all the time. Okay? And your method cannot be looking at the person beside you, cheating. If you have a method that's not cheating, works for you, do it. But I'm going to show you, and I want you all to be aware, because this method works for tougher problems than just changing centimeters to meters. Here's what I'm going to suggest, and I left it out space, even if you know the other way. 2.3 meters to centimeters. How many centimeters? Now, I always just quick ask myself, if I had more than 2 of these sticks, do I have a lot of centimeters or a little bit of centimeters? You say, I have a lot, right? Because it's that much, 2.3, okay? I know the number is going to get bigger, but that way you can check the answer. I'm going to write down this fact first. 1 meter is 100 centimeters. I'm going to use that, right? So let's go to that. I'm going to put this down as a fraction. 1 meter, 100 centimeters. I take a fact out of that little box, the colored box, and I'll listen for this.
So are you going to Mr. Thomas? You call the office, Mr. Thomas. Thank you.
Okay. Then on the other side, I'm going to create another fraction. I'm going to convert 2.3 meters to centimeters. Now, if I have meters on the top on the left side for my fact, I'm going to make sure I put the meters on the top on the right hand side. So more than the conversion, I want to teach you a method how to set these proportions up. And then I'm going to say centimeters on the bottom, the X on the bottom. Now this is a fraction system, and this will help you out future classes a lot. Nothing to do with the metric system. The way to solve one of these, do you guys know how to just solve it without doing a bunch of algebra? You can do algebra to solve it. I'm going to just tell you. What's that? Okay, because you might know it. X. I make, instead of an X like this, I get confused in math because it looks like a multiplication sign. So I make mine like a handwritten X. You can make yours like a multiplication X. X is my variable, my unknown. Okay. But you'll never mistake mine for the times. Back to this. Here's the phrase that pays. Cross multiply, divide by the lower. To solve, if it's a fraction system, a proportion, without any addition or subtraction in it. Why is it set up like that? Here's what you do. Cross multiply the diagonal things. And then divide by the lower. Now, dividing by 1 doesn't change things. What you're going to do is go 2.3 times 100. And you can probably do that in your head. You could use a calculator if you can. And like I mentioned before, if you can do these without setting these up, go ahead, but I'm just showing you how to set these. So I'll go 2.3 times 100 is 230, divided by 1. Well, it's still 230. And that's centimeters. That's what I want. Okay? Like I said, Charlotte, if you know a different way, stick with it. But this is a method with easy problems first. I don't go the tough problems next. It's more the method that I want. Now, converting centimeters to meters uses the same fact that there's 1 meter to 100 centimeters. So I'm going to put this in as 1 meter, 100 centimeters, and you are too. Then, this is 255 centimeters. I need that on the bottom because the centimeters are on the bottom. So I'm going to put my 255 centimeters on the bottom. On the top. Okay, according to what I said, cross multiply and divide by the lower to solve anything like this. And there's an algebra reason why this works. You don't have to worry about that. 1 times 255, then divide by 100. Now, if you know how to divide by 100, you just move the decimal 2 spaces. And you could do this directly without setting up the proportion. But we're going to need to know how to set up proportions next. So that's 2.55 centimeters. Multiplying and dividing by 1,000 and 100 is really just moving. Now, I'm going to set up a couple more. I'll leave the other ones for you to finish. Any method you'd like. So these next two, convert decimal 63 centimeters to meters. Well, I would look up at the top and I'd say, well, centimeters to millimeters. The colored box. 1 centimeter is 10 millimeters, if you didn't remember. And then I say, the decimal 63 centimeters, that's the top of the left side of the fraction, so it has to be the top here. And what I'm looking for is matched with the millimeters. I know that it's cross, multiply, diagonal, divide by the lower. So what's the answer in this case? 20 millimeters. Decimal 63. Decimal 63. Well, that's not even a full centimeter, right? That's about where my thumbnail is. See, it's tiny, right? It's not going to be a lot, but it's going to be what? 6 decimal 3. Decimal 63 times. Nope, I'm going to change to the other. 6.3 millimeters. I'll do this other one and then I'll leave the other two for you. Meters and millimeters, and that's 1,000. 1 meter, same as 1,000 millimeters. I won't make you sit and count them, but there is 1,000 on the stick. When I say, well, 0.35 meters must go on the top, because it's on the top left. I cross multiply 0.35 times 1,000. If you need a calculator, go ahead, but otherwise move the decimal 3 times and get 35. That is millimeters. Okay? I am going to leave these for you to come back to. So you've got to finish them. Okay? And they're similar to the ones above. But don't do them right now. Or don't pause the video. Do them right now. Okay? That shouldn't take you too long. I'll just go ahead. Okay, after switching textbooks, guys, the photocopy error that didn't show up. I'm going to put page 318. However, we're going to adapt this a little bit because you're not going to draw on your textbook. Okay? Now, I think you guys, this isn't a big deal, I don't think. I think you see if this is small a right here, then this is big A, right? Big B will be the long side here, big C, big D, and big E. Okay? Now, don't do that in the textbook. Page 318. Everything else you guys have, right? The right on your hat. I don't know why I worked on it. So we kind of did this by visually watching video. Measure the lengths of pairs of matching sides on the drawings. So we're going to need rulers. We should use millimeters. For each measurement, write the fraction, then write the decimal for the fraction using 2 decimal places. Now, I made up some numbers. So you'll like have big letter to small letter. And then you're going to have the actual measurements, and then divide them on your calculator and get what this is, okay? Here's the formula that you're going to do in words. But this means each millimeter marked ruler. If you don't have one, and you're going to just do this for the next little bit, if you don't have one, borrow one of mine, I'll get you one. So already I know a lot of people finished, and some people are just midway. So big A to little a is 30 millimeters to 15 millimeters. When I divide that, it comes out to be 2. I don't even need 0.00. So I did say if it needs to, but these are bang on. So. I'll ask for more in a few minutes, but I want you to finish these up. Okay? Just like that. You guys are done or not? That's not cool. Because this shouldn't be taking us, but whatever, it is taking us. Surprise. Okay. Get these down. I'm going to start writing some answers down. I just did B, so I have it in my head. I won't ask. I just did B, U. We have 50 millimeters to 25 millimeters, which divides out to be a perfect 2, no decimals needed. Somebody help me out with C. Yep, wrong. 40 and 20, okay? That comes out to be 2. Elijah, help me out with D and D. What's that? Still comes out as 2, but what is top and bottom measure? You're not done, are you? Top and bottom. Okay, you guys, I'll get somebody else to go on. Yeah. So D was also 40-40? Or, I mean 40-20? Just like C was? Okay. I don't remember. I can't see the shape right now. And then that little tick marky one, or tick marky, the diagonal one. What were these? Now these ones, yeah. No, 14 and 7. Ah, there we go. Okay, I think you noticed already that they are the exact same division, the decimals. Well, there was no decimal, but 2 even, 2.0, right, every time. How much bigger is that shape than the other shape? 2 times bigger. That means literally every side is twice as big. Okay? But that you can do in your head because that's a 2. And I like starting with easier. I do see, and we're going to actually use these skills next week. We'll be getting into more drawings with rulers and stuff. It's really important we got this down. Right now, I'm going to do a quick review. It's on the next page. What we just found is called a scale factor, or a recap. I said a review. Recap of something. And it represents the ratio of distance measurements of shape and its corresponding distance of a similar shape. But both measurements have to have the same units, like millimeters, kilometers, centimeters. If one is in meters and one is in centimeters, you've got to choose one and change the other two. Okay? When determining the scale factor, we're going to use the letter K sometimes. Using for a scale diagram, the measurement of the original shape is placed in the bottom, the denominator. So that's important, because if you had it the other way around, you would have come up with decimal 5. That this way, if you do it, it means that something is 2 times bigger than the original shape in the other 2. Here's some facts and vocabulary. If you want to, without using fractions, you can multiply any dimension of a shape by the scale factor, so the 2 in that example, to calculate the corresponding dimension in the similar shape. So once you figure out that 2 or a decimal 5, a diagram that's an enlargement or a reduction of another is called a scale diagram. With an enlargement, you're going to get a number that's bigger than 1 when you take the ratio. With the reduction, you're going to get a number less than 1. So like decimal 75, decimal 5. Matching lengths on the original diagram and the scale diagram, they're called corresponding lengths. The fraction comparing the lengths on the scale diagram is called the scale factor. So that's like that 40 to 20 or something. And you can express it, scale factor as a fraction or a decimal. I actually like fractions better. That's me. When 2 fractions are equal, it's called a proportion. And I started with centimeters and millimeter conversions and stuff with proportion. Okay. I already mentioned this. Your number is bigger than 1 for the scale factor. It's an enlargement. Smaller, it's a reduction when it's between 0. Now, I'm going to end it off here because on Thursday we'll see. We're going to start working through these things together. Okay, but that's Thursday. Now, it's just no use going through this.